Hello, ma'am. My presentation is about phishing detection using machine learning. I have made this presentation by referencing the given research paper, and I have found certain things which I shared within this presentation. This presentation is essentially a summary of the given research paper. Before starting the presentation, I want to first showcase the objectives of this presentation. First, we will I will first introduce what actually is phishing and why it's very important to stop phishing. Then the proposed technique by the researchers in the research paper. Then discussing the results, and finally showcasing the results, and then concluding the presentation. Let's start with the introduction. The question is, what is phishing? Well, phishing is a type of cyber attack. Now, as the economy is digitizing at a rapid pace, crimes, digital crimes are also increasing rapidly. And one of the digital crime is committed using phishing. Phishing generally means that a person or a group is impersonating another as a legitimate entity and using that identity to take something valuable from other people. Thus, it becomes very important to create security measures that can counter these attacks in order to maintain users' privacy and also to limit financial digital crimes. Right now, the typical service that is used to stop phishing are blacklisting services. There are many repositories online, open source repositories, which store all the phishing URLs that are encountered by many developers and security experts. And one of the popular repositories is PhishTank. These blacklisting services have an API which is connected to such repositories. They will constantly scan the viewport of the user, and if they find any URL which is present within those phishing repositories, then they will raise a flag and alert the user. The problem is the amount of time that it takes for these phishing URLs to enter into these repositories is very high, and before that the phishing attack already concludes. So new phishing URLs are made, and within a span of a day, the phishing attack gets completed. Due to this, these phishing URLs, even though are reaching the phishing repositories, are rendered useless because these phishing URLs are not again used in most of the cases. Thus, it is a very big limitation of these services in order to counteract the phishing problem. Machine learning proposes a very novel solution for this particular problem. Machine learning algorithms are capable to identify and learn the patterns and use that knowledge to classify whether something is belonging to one class or another class. Thus, we can utilize this ability of machine learning algorithms to learn the patterns of existing labeled phishing URLs and legitimate URLs and use this knowledge to classify unseen URLs as legitimate or phishing. But first, let's have a deeper understanding about what is phishing. As I already said, phishing is a form of cyber attack where a individual or a group of individuals impersonate a legitimate entity in order to gain valuable information from users. Now, this information is typically used to gain financial outcomes or for other purposes. Some of the examples are phishing emails, phishing websites, p-phishing, smishing, and wishing. phishing emails and websites are interconnected, the process is an individual or a group of individuals will spoof the email, making it seem legitimate, and send emails to a selected group of users. User will think that this came from a legitimate source and he would click on any of the links provided in order to do the needful. And when he goes to that web page, these links generally direct him to web pages which look highly similar to the legitimate ones. There he gives the information, and that information will go to these group of individuals, and these criminals will use that information for nefarious purposes. The technique which was proposed in the paper was to use machine learning to accurately identify which URLs are phishing and which URLs are not phishing. For this, they wanted to use a supervised machine learning algorithm. Now, let's go step by step in order to of this proposed technique to better understand the approach the researchers took. As this became a machine learning problem statement, it becomes very important that to have a data set. Now, what the data set, as you are using a supervised machine learning algorithm, the data set must contain data which is labeled and have two classes within it. One which one URLs which are legitimate and another which are phishing in nature. Now, the data set must be representative, diverse, and granular in nature so that the model can able to learn these patterns much more deeply and be more generalized in nature. So the data collection process is very important because as we need data set and we need to build this data set. So for that, it becomes important to collect the data. And as I already stated, in order we need data which belongs to both categories. One legitimate and another one is phishing. The process of data collection. So here researchers stated that apart from taking the URLs or the data set from established sources, one can also use automated web crawling. Basically, create a spider using Python's Scrappy framework and leave it to scrap or to monitor the internet, and whenever it finds certain URLs which are not legitimate, send them back to the researchers. By this, we will have much more real-time data. And to make the data set much more relevant, they place certain inclusion criteria so that data set does not diverge and is relevant to the stated problem statement. And obviously, as this scraper or from this scraper is scraping the URLs from the internet, there are certain cases where the URLs are erroneous in nature and exhibit illogical features which can make our model irrelevant. So it becomes a very important step to handle these URLs by identifying what they are leading to. Now here these points are important for to maintain the quality of the data set. For real world variation and generalizability is very important. Until and unless we have a data set which has innate diversity within itself or granularity within itself, the trained model on this data set will not be able to better generalize. At the same time, it is also important to have a balanced representation. Since this is a classification problem statement, it is imperative that we have a balanced data set. Because one of the examples generally given is, suppose there is a problem statement where 90% of the time the outcome is 1 and only 10% of the time the outcome is 0. Hence, the data set that we have is not balanced in nature. Now, the model will only learn to give 1 all the time, and of because of that, the accuracy of the model becomes 90%. But the model is not generalized. The model does not generalize better and is a illogical and irrelevant model. Thus, it becomes very important to have a balanced representation within the data set. So once the data has been collected, it's very important to pre-process. So researchers stated certain pre-processing techniques that they have used. First, obviously, is to handle the missing values. Sometimes from the URL, sometimes the algorithms that are used to extract the features from the URLs might not be able to extract certain features and leave them. In that cases, we have to use imputation techniques like mean, median, or mode in order to impute the missing data or remove the incomplete data points from the dataset, whichever is suitable or relevant. Next is normalization. As we have diverse data points or belonging to different categories, the level of the data changes by every column. It has been observed that if the data, if the features level are equivalent, if that is the importance of features is equal for each importance of feature, or the weight given to the each feature is equal, then the model better generalizes. Then that's why it becomes important to normalize these features or standardize these features according to the uh, type of the features we are dealing with. Next, encoding categorical variables. Now, machine learning algorithms are not capable to understand text data. So it becomes important to encode these text or categorical variables into numerical variables. And for that, there are many techniques like one-hot encoding, label encoding, etc. Any of these techniques can be used to encode the categorical variables. Next is feature engineering. Feature engineering generally has two steps. One is feature selection, another one is feature scaling. Now, this is important to extract specific features from the dataset which are relevant to our problem statement, which are very important for our problem statement, and also to scale them, that is, normalize them in a way which makes our model much more accurate and let it to generalize better. More on that in the next slide. Now, one of the process in feature engineering is feature selection. So here researchers proposed, not proposed, but they stated that these are the techniques that are available, and we utilized these techniques to select the relevant features from the dataset that we prepared. Now, feature selection is important because generally it's been observed that even if you have hundreds and thousands of features within your dataset, only a subset of them are relevant to the problem statement. That is, they are highly correlated with the target feature. Hence, it becomes very important to reduce the clutter and only choose the features which are relevant for the problem statement in order to make the model much more accurate and generalized better. For that, following techniques are used. One is recursive feature elimination. Recursive feature elimination, it's a technique where features are recursively removed from the dataset. That is, least important features are removed from the dataset by utilizing a importance score, and it continues until said number of features are reached or a predefined performance criteria is met. Now, this allows us to reduce the clutter, remove non-important or non-correlated features, and make our model much more better. Next is principal component analysis. This is a very popular uh, popular feature selection technique. It's essentially a dimensionality reduction technique. It is also a unsupervised learning technique. It utilizes the property of eigenvalues and eigenvectors, where it tries to capture the variance of the it tries to capture the variance that is provided within by the features with least amount of principal components, and these principal components become our new features. This is much more accurate in nature. Even though it's a complex reduction technique, the results it produces are better. Next is forward selection and backward elimination. Now, these techniques are very uh, rudimentary in nature. In forward selection, uh, we first assign certain scores to each and every feature, stating which states the importance of that feature, and we constantly iteratively add most important feature into our dataset until number of features or criteria is met. Now, forward selection is generally a better way than backward elimination. Now, in backward elimination, we first start with all the features, and we iteratively remove the least important features until a certain criteria is met. And as I already stated, forward selection is much better than backward elimination. Then lasso regularization. Now, lasso regularization, as the definition states, penalizes the absolute magnitude of feature coefficients in the model. It assigns itself to the cost function and make sure that least important features, their corresponding coefficients are iteratively made to come near zero, such that these features become less important and do not impact the model's accuracy. Due to this, overfitting is avoided, and we get a model which is much more efficient and generalized, and also it makes the representation to be much less sparse. Then is feature extraction. In feature extraction, what we do is, among the collected features we try to extract among the collected features we try to create new features from extracting insights, or combining two or more features, or extracting information from two or more features. Now, in this particular problem statement, we have features in the form of, we have different categories of features. One is URL features, another one is content based features. So, as the name suggests, in URL features, it basically includes length, domain age, presence of hyphens, special characters, number of subdomains, etc. Now, these features are very important and indicate whether the URL is legitimate or not. Now, content-based features basically try to extract information from the HTML source code or the metadata of the web pages. Now, we try to find certain keywords or phrases which are present, which are generally used in phishing websites, and also redirects and random redirects to unknown locations. This type of information is captured and extracted from uh, these features, and it has been observed that content-based features are more capable and more correlated with the phishing classification. Obviously, as it's a machine learning problem statement, we also need to select a model which is capable of performing well in these scenarios. So the researchers have used SVM, support vector machine, for this purpose. Now, this is a supervised learning algorithm and is used for both classification and regression. The intuition is it tries to create a hyperplane which separates data belonging to different classes while while maximizing the margin of the hyperplane. Due to this, the overfitting problem reduces, and this particular algorithm is well suited for binary classification. The following are the advantages which were proposed in the research paper, which were said in the research paper, due to which researchers have selected SVMs as their model. First, effectiveness in high dimensional spaces. It has been observed that SVMs perform extremely well in high dimensional spaces. Due to this, as our dataset contains multiple features from URLs and content, it becomes very important that we find a model which can find an algorithm which can work in high dimensional spaces, and SVM can do that. Next advantage is robust to overfitting. Any machine learning researcher never want an overfitted model, because an overfitted model is a dumb model and cannot generalize better. It works well with the training dataset but is not at all useful in the real world. Thankfully, due to the property of maximizing the margin of the hyperplane, SVMs avoid being overfitting. Now, accurate in non-linear scenarios. SVMs can effectively handle non-linear classification tasks because they are integrated with kernel functions. Now, these kernel functions essentially try to transform the high-dimensional non-linear data in a way that is easily dividable, easily segregatable, and this allows SVMs to predict or classify much better in non-linear scenarios. Now, in phishing detection, the features that we have not necessarily have linear relationship among them, as and they have come from different categories. So we could say that the data set have non-linear features, and SVMs play a very big create a much more accurate model in these scenarios, and that's why researchers have selected SVMs as the model, as the algorithm. Again, another advantage that they stated that was SVMs really work well with these small data sets, because because sometimes we may not with the required features that we may not find data. We may have the diverse data, but the amount of data might be less. In these scenarios also, SVMs perform better. And obviously, interpretable results. SVM provides interpretable results, allowing users to understand the decision-making process behind the classification outcome. Next is discussion, robustness, and generalization. In this, researchers have stated uh, how to validate or how to evaluate the performance on unseen data, and how to increase the performance of the model on unseen data. So they stated that while training the model, it's important to use cross validation, holdout validation, and hyperparametric tuning, which will make sure the model does not overfit and be more generalized in nature. And obviously, SVMs inherently generally don't give overfitted models. But even if that happens, then they stated that utilizing regularization techniques like L1 and L2 generally resolve this issue. So what are the benefits of this approach? Due to the utilization of SVM as an algorithm, researchers have observed that the detection accuracy has increased significantly, and the amount of false positives also reduced significantly. So let's discuss the results that the researchers have faced. The proposed techniques achieves a high accuracy rate of 95.66% in distinguishing between legitimate and phishing websites. This accuracy rate reflects the model's ability to correctly classify a large majority of web pages into their respective categories, indicating its effectiveness in identifying potential phishing threats. Now, the below table showcases the algorithms that the researchers used and also the accuracy that they have received. As we can observe, SVMs with only 5 features was able to was able to give a model which was more accurate than than other classifiers. Conclusion: achieving a remarkable accuracy rate of 95.66%, highlighting its effectiveness in distinguishing between legitimate and phishing website. And SVMs have really proven that in cases of phishing detection, they give a much more concise, more packageable model to use. And due to the less size of the model, it is highly scalable and can be used in various sources. Again, it's very important to be aware of these cyber attacks, and SVMs have proven that machine learning can be used to detect and stop the cyber related crimes. With that, I want to conclude my presentation. Thank you, ma'am.